Hey everyone, this is Team 19862 Mecha Mantises. My name is Navya, and a fun fact about myself is that I have a dog.
Hey everyone, my name is Aditi Malaka, and a fun fact about me is I also have a dog.
Hey everyone, my name is Anites Pota, and a fun fact about me is that I love to play tennis.
Hello, my name is Aryav Jain, and a fun fact about myself is that I like to play badminton.
Hi, my name is Aryan, and a fun fact about me is that I'm left-handed.
Hi everyone, my name is Shreya, and a fun fact about me is that I like to play volleyball.
Hi everyone, my name is Neil and I like to play the piano.
Hi, my name is and a fun fact about myself is that I like to play tennis.
So that's a little bit about our team, and here's a quick recap of our FTC journey. We've been in FTC for about 1 year, and over the course of this year, we've gained a lot of knowledge and a couple of new members. So now let's move on to our agenda for today.
Okay, so today we're going to be covering multiple topics, which includes like what is software. Then we're going to be going through the FTC simulator and how to install and set that up. Then we're going to be talking about TensorFlow and what it is. And lastly, we'll have a fun Kahoot to see what we've learned. Okay, so
The software of a robot tells the robot what to do, whether it is to move forward, move back, lift its arm, or more. The programming language FTC teams use is Java. The IDE, or also known as the Integrated Development Environment, our team uses is Android Studio, but others include IntelliJ and more. The libraries teams use are provided by FTC, the FTC SDK. Lastly, there's two types of program our team created for last year's mission. They were called the autonomous program and the manual program. In the autonomous program, the robot needs to do certain tasks by itself, so the code written for the robot does not need to be controlled. However, for the manual program, the robot was controlled by team members, controlling where it went, how fast it was, and a sequence of things it did. To test our code, our team used the FTC simulator, which has the same layout as a robotics competition, and a robot that would run the code inputted. The FTC simulator shows whether the code that was given was functioning properly. This has helped us throughout our FTC season because it has allowed us to try our code on a smaller scale robot before using it on our real FTC robot. This allowed us to fix any errors in our code and test our code many times as we wanted without needing the robot to be present. Software libraries and software development kits are important because they help us code more efficiently. They allow us to use code that other people already made while understanding that code as well. This means we don't have to recode the complexity and can add our own unique ideas. Some useful libraries and SDKs include the FTC SDK, which is the development kit that FTC provides, TensorFlow, which is an AI image detection library that helps us detect custom elements for the game. We will go further detail into that later. Roadrunner is an odometry library that will help with odometry precision to make a robot move more precise using motor encoders. Euphora is a development kit that allows us to get live feedback from our camera sensor. Software libraries enable us to use pre-written code to speed up coding. Just like we created, they have the same pre-written code to stop us from unnecessarily repeating the same code.
okay, so now we're gonna start. We're gonna demonstrate the FTC simulator. So first, what you want to do is that you want to go to Java 8 and you want to install Java 8 from Oracle. So you can do that by just going to Oracle, and then you just need to scroll down. The link will also be in the description of this video. Then you have to find your operating system and download the correct file. So like I'm on a Mac, so I would like install this, but like if some of you are on a Windows, you would install this one if you're like probably 64-bit, or if you have any other operating system, they're all listed here. And yeah, you just download that, and then you'll be walked through like an installation process, and then you just install that. You also have to make sure that you have an Oracle account in order to like download this. So yeah. Okay. So once you have that installed, you just accept the agreement, download the file, then you run the exe that's in your file manager, and then you go through the installation process. So once you're done with that, you want to install Android Studio. That's the IDE we'll be using like in this tutorial. So you just want to go to this link also in the description. So once you're in the link, so you just want to go here, then you just want to click download Android Studio. It'll probably install like an exe or a DMG if you're on a Mac or Windows. Then you just want to run the file and then walk through the setup instructions and then install the IDE, which may take a few minutes. I won't be doing this since I already have it installed. So next you want to go and download the FTC simulator, which is a GitHub link. So just go here and then it should be on GitHub. Then in order to download this, you just want to press code and then download zip. Once you've downloaded that, it should start downloading in your downloads. You can see up here. It's downloading. Once it's okay. So that'll probably take some time. And then once you download the zip, it's downloaded for me. You just want to double click it and extract it. So mine is extracting. So once that's done extracting, then hopefully you have your Android Studio installed by now. So you want to open up Android Studio. I already have it installed, but you just want to click File. Mine is still loading, and then you want to click Open. Okay, then you want to click Open, and once that'll probably open up a window which you can select your file. So once that's done opening, yeah, so you should get something like a window that looks like this. So you just want to go into probably your downloads where you extracted it, and then you want to find your file with your virtual robot simulator. So I already have that open, so I'm just going to click cancel. So once you have this open, and then it should be loading at the bottom, so you just want to wait for that to finish. So then you just want to go again to file, and you want to click project structure. So once that's done opening, it should open up another window. It may take some time if your Gradle is still building, so you can just wait for that. So once that's done, it should open up a window that looks like this. You want to make sure where it says project SDK, you want to make sure that it says 1.8 from the Java 8 you installed. If it says 1.0, you can just leave it, or if it's not, you just press add JDK, and then you just click the 1.8 that you installed. Most probably it should already be there for you. So you can just X out of that. And just make sure to apply your changes if you added it. Okay, so once that's done building, so we're just gonna test a quick Atelier program right now. So you can just click the run button. That's in like the top right corner next to main. So you know it's building because in the bottom here it should have like this bar, and if you hover over it, it should say like build, yeah, and then you can if you want to click it, you can see the background tasks, or you can just go to this build icon here, and it'll like tell the steps that where you're like building it from. So like while that's building, I'll just explain what this is. So basically this is the Android Studio IDE as I explained, and all of this here, this is basically a simulation of the FTC SDK. So most of the layout's the same. You'll be in the team code folder. A lot of it's going to be different, for this is like running on Java 8, which is on your own computer rather than the actual robot. And instead of main, you have to connect your robot like wirelessly or wired, like using a USB to USB-C, depending on like if you have a control hub or you're using like an Android phone in order to run it. And over here are all your like files. I have a few files from like before when I ran the simulator, because like we use it for our team a lot. So then yeah, so these are just raw files. The layouts like are almost the same according to like the real FTC SDK. So it's not that much of a difference. Okay, that's still building. On the first like initial build, it'll like take a long time because it's still like opening your like Java 8 and everything. So you can just wait that for build. You can like see the bar over there to see like how much progress you're at. Okay, I'm just gonna go back to this. So we already did this. We built it. Okay, and then yeah, you just wanna like open this, and it should open a window that looks like this. So that's still building. Okay, and it's almost done because you can see in the log over here that it's saying finished saving, executing, and then, oh, you could barely see that, but it said launch succeeded over here. And then it should open a run tab, and it should, once this is open, it should just say like initialized virtual gamepad. And then it should have also opened something called Java. So in a few minutes, you'll get like a big white window that has like it has the game field. This is normally updated every year. So this is last year's season, the 2021 to 2022 season for Frenzy. But like in the new season, this will be updated eventually. So that's why like we also use this, because it like updates to like every season like continuously. So we're always up to date with the newest like missions and like the map. So now that that's opened, it's like a window that looks like this. It's called Virtual Robot. Mine is still loading. Yeah, and you should get a window that looks like this. So first, what you want to do in order to test the autonomous, we're going to be using a two-wheel bot. So over here in where it says configurations, you want to click Mecha bot, and then you want to click two-wheel bot. And then where it says this will be different for you, it's randomized. So you just want to click that and make sure it's two-wheel bot. Okay. Okay. Oh, you have to scroll down and see that. Two-wheel demo op mode. So this is probably shorter for you, but if you don't see it at first, you want to scroll down until you see a two-wheel demo, and then you want to click in it. So once it says that, then you want to just click start. Now you have these controls at the bottom. You can use this to move the robot. So in the two-wheel bot, at least you can use like A to go backwards, X to turn left, B to turn right, Y to go forward, and then you can use one of these to control the arms. Yeah, if you see like that's like moving the arm back and forth. Yeah, that's basically your first Telia program. This is also called a manual program, as we said in the beginning, because you're like controlling this by yourself, and there's no like pre-made code in order to run it. You're only like using code that you can control it yourself. So you can play around this for a few times, see what it can do, and then you can just press stop. Yeah, then you want to go back here, and you want to, in order to create your first autonomous program, you want to go where it says org.firstinspires.ftc.teamcode. You want to right click there. It should like have like a loading symbol saying that it's opening a window, and then you should see here, and then you want to see new, and then you want to click Java class, and then you can give it a name, whatever you want to. I'm just gonna call it autonomous tutorial. And I'm just going to press enter. That should create a file here in a bit. It might take a while. Yeah, see, so it created a file. This is called autonomous tutorial. Okay. So then the first thing you want to do is that you want to see here, and then you want to make sure it says extends linear op mode. This basically says the what op mode you're using. That means the code will run linearly, and then you'll also have like different classes, which is like the initialize, then the actual run, and then you should see this is red because we didn't import this. To import this quickly, you can just press Alt Enter, and you can just press import class. And then it should have an import statement over here, and the red should go away. There's going to be like an underlined red because you have nothing inside of this saying that it's a linear op mode. So we're going to like write that code in a minute. And then also what you want to do after you do that, you want to label this as what type of program you want. So if you would do a teleop program, you would say at teleop. If you're doing an autonomous program, you do at autonomous. So this is an autonomous program. So we're going to do at autonomous. So if that doesn't pop up, it should probably give like a drop down menu, but if that doesn't, you can just press at autonomous, and then you want to put parentheses, and you want to say name is equal to, and then you can name this whatever you want. It doesn't have to be the same as this file, so I'm going to auto tutorial, and that's all you need. And then next you have like this autonomous, it's red again, so you can just press Alt Enter and then press import class. Okay. So then you want to press enter, and now you want to define your run op mode method. So then you want to write public void run op mode. So you want to make sure all the capitalization is the same. So O is capitalized, M is capitalized, R is not capitalized. And then you want to put parentheses around. And then you want to put those curly brackets. And then you just press enter. This should remove the red lines here in a bit. Yeah, see, so basically that red line went away now that we defined like what's inside of this. So now you want to define your like motors and stuff. So this is basically what we call hardware mapping. So first you want to define your like motors. So you want to say like DC motor, left motor is equal to, and you want to say like, and then you want to hardware map it. So again, DC motor isn't imported, so you want to press Alt Enter, and it should import it. Eventually, you won't have to keep on pressing import, and it'll just do it by itself. So then you want to say hardware map dot, and then basically, then you want to write DC motor because that's the thing we're like defining. And then because like since this is a DC motor, you want to make sure it says DC motor here. If we said servo here, this would be servo. And yeah, so then you want to say DC motor dot get, and then this is basically what's going to be either on your robot, but in this, so basically like in this it's defined as left motor, everything lowercase, but on your real control hub or when you're working this on like a real robot, you'll basically define this on your control hub and you would put the same thing like imported. This basically tells your robot which like a motor slash servo or sensor or anything is connected to which port, so that then you can like control the specific motors and like things on your like robot motors and sensors. So we're going to do a very basic hardware map, and we're just going to use two like motors, one right motor, one left motor. So right motor is equal to hardware map dot DC motor dot get, right motor. And if you're not familiar with Java, just remember you have to put a semicolon at the end of each line, or it'll like give an error. And then also what you want to do is that you want to make sure you set this left motor to reverse, because if you think about it, like since the two motors are facing opposite directions on a robot, one of them has to be reversed in order to go the same direction. So you want to make sure you say left motor dot set direction. Make sure it's the same capitalization. And you want to say DC motor, again saying that this is a DC motor that we're talking about. And then you say direction dot reverse. And you want to make sure reverse is capitalized. And then again, semicolon. And also later on in this video, we're going to be using encoders. So you want to make sure that you're saying left motor dot set mode. This is basically setting the mode that we're going to be using an encoder. But first you want to say that we want to stop and reset encoder. So if you just say stop, it should like pop up over here. You can just click on it. Oh god, no, that's the wrong one. You want to click on this one and then just press enter. And then you can just copy paste this line if you don't want to retype all of that out again. And just copy and lagging. And then enter, paste, and then just make sure to change left to right, because then you won't have anything to define the right motor. You can just change that to right. And now you want to say that you want to use the encoder. This basically resets the encoder to make sure you don't have any values if you run this program continuously. So dot set mode. And you want to say run using, and it should like pop up on the bottom here again. Yeah, run using encoder. So just enter semicolon. Always make sure to have that semicolon there. Enter, and then paste, and then change left to right. This basically initialize. So basically what we did right now is that we set our hardware maps, and we like set like all like the prerequisites to like the motors to make sure that they'll be functioning properly. So now what we're going to do is that we're going to set up our initialize statement. If you remember in the teleop program, we pressed a button called, actually I'll just show you again. We pressed a button called init here. This basically initializes your robot. You can show like telemetry updates and everything here. And it's like a good way in order to see like your robot's functioning properly before you actually start it, because in a real game you won't always have like you won't like always like it might not always work when you like start it for the first time. So having an initialize statement is always a good idea. So once you have that, you can set up your initialize statement. We're just gonna put a while loop, and we're just gonna check while the op mode, which is basically the mode that like run, is active. And when you put an exclamation mark in front of it, that's called a bang, and that basically means that like no, like when this is not true. Oh, I don't know why I wrote an F there. And then you want to click, you want to press the and button 2 times, so basically shift 7 on most keyboards. And that basically says it has to be this and another argument, which is like, then you want to put bang again and is stop requested. So this basically means that this is going to be before it actually starts and before it stopped. That means like the initialization time. So then again, you want to put the curly brackets, and then you want to add something in the telemetry showing that it's been initialized. The add data. This is all your initialization state. This is all your initialization statement, and this shows that it's like all been like it's all happened. And then you want to just put initialized, and then you want to put a value. Ready to start. Ready to start. This basically in every telemetry statement, you want to put a caption and a value. Most values aren't going to be like strings. There might be like a value like a sensor input, a time reading, or anything. But for now, we're just going to put like a string since we don't have anything else. And then you always want to make sure to update your telemetry, or like whatever you said here won't even show. So you always want to make sure you put telemetry.update and then the two parentheses. Okay, now that's your initialization statement. And then you wanna wait, no. So then you wanna wait for start. And there, this is basically waits until it fully starts. We have an error here. Oh, so basically you don't need this actually for now, because we already put our we already put a while loop here. So basically like the wait for start isn't needed. You can either use this or wait for start. They basically do the same thing. And then you want to say left motor. Okay, so now what we're gonna do is that we're gonna be actually running the robot. So we're just going to say, so we're going to do a very simple thing based on time, and we're just going to say we're going to run it for 5 seconds, and then we're just going to end it. Okay, so we're just going to say left motor dot set power, and we're going to say 1. So basically in FTC, the like lowest value you can go is -1, and the highest value you can go is 1. And then if you want to go like 80% power, you want to put 0.8, 90, 0.9, etc. So it doesn't go to 100. If you have an FLL, it goes to 100, but in FTC it does only till 1 or -1. And then you want to do right motor dot set power 1, and then make sure to put your semicolon at the end. I forgot. Okay. And then to make sure it runs for 5 seconds, you just want to put a sleep function for 5,000. And then we're just going to put a semicolon, and then we're just going to say to stop. And there, that should be your first autonomous program. So we're just going to click this run thing, like the one that looks like an arrow, like a U-turn arrow or something. And then you just click that. And then you can just say stop and rerun. It should probably build a lot faster this time since we already built it the last time, so a lot of it is already cached. It may still take some time because we added new code as well. It's parsing. You can always check the build to see what step it's at. Okay, so now that that's done, it's done building. Now it's gonna run. It may take a while. It's still loading. Okay. And we can just return here. It should be over here. And it should show up eventually. It should be called Java again. It should be the same exact thing, except now we'll have a different program. Okay, so now it showed up. It's the same window, same thing. It's just that once it's done loading, we'll have another program in our like directory. So you want to continue with two-wheel bot since we only programmed 2 motors. So you just want two-wheel bot. And then you want to find the auto tutorial. So I named mine auto tutorial. You could, whatever you put here is what your program will be named as. So then you just want to press init. As you can see, it says initialized ready to start as you put here. And then you want to press start. Now your robot is going to go forward for 5 seconds and then it automatically stops. So basically, it went forward for 5 seconds and then it stopped, as we said in our code. And this is going at full power. If you want to reduce the power, you can set this to like 0 0.5, 0 0.1, 0 0.2, etc. And then, so that's basically just going forward for 5 seconds in a straight line. So if we go back here, so basically I've mainly explained a lot of this like as I was talking, but this is basically the software design. So you have two programs that autonomous and manual. We'll be going into TensorFlow in a deeper, but usually during autonomous you would want to use some detection software like artificial intelligence to make it detect stuff by itself. So we use TensorFlow and that uses the Mantises class. So basically, in order to make your code much more efficient, you want to use classes. What classes do is that, so this is like our example of a Mantises class. This class allows us to have functions, which makes it more efficient. So you just have parameters, so you don't have to repeat huge blocks of codes over and over again. And then it also allows us to have our initialize statement like not inside, but we can like do that in a separate file. So our code looks much cleaner and like much nicer, and it's like less confusing and less complicated. So both of these use the FTC SDK, which it's also, this is the one that has TensorFlow in it. And yeah, so basically the FTC SDK provides all the servos, motors, and sensors so that the programs and the Mantises class can use them. And then the FTC SDK uses the hardware map in order to find all like the ports, servos, motors, like sensors, all those ports for all of that. And then lastly, the robot hardware uses the FTC SDK in order to run the actual thing on the robot. And in this case, the robot hardware is our Java 8 simulator. So going back to our simulator. So basically there are a few problems with this code. So we're gonna talk about that. So this is basically our software evolution and what problems we found like with the code that we use and like how you can evolve that. So the first one is that motors are heating because of continuous running of motors. If you notice in our code, we never actually stop the motors. Stopping the motors is what you can say like setting the power to 0. This caused like many problems with the actual motor because we left the motor on and then we were overheat and they would burn out and like go bad, which is like a wastage of money and time because we would have to switch out the motors, buy new motors, and just by adding 2 lines of code, this will like save a lot of hassle for you. So you just want to click left motor dot set power, like after you ran it, set power, set power, and you just want to say 0. And you want to do this for both the left and right motor and or however many motors you have. You might have it for like arms and everything. So once you're done with your program, make sure to always set the motor powers to 0. This helps a lot and it'll like save a lot of time in the future. Set power is 0. So this is basic. This won't cause any difference in your code. It'll just help in like a real robot situation, but like doing it in the simulator can help a lot. Okay, so the second part is an inconsistent distance while running the motors using a time sleep function. So basically, if you see here, we're using a sleep function, but let's say like as we saw, it ran into the wall over here. Now technically the motors aren't moving, but the sleep function thinks that the motors are still moving. Therefore, if you like go into a wall in a real game, your like robot won't like know that it's moving, and this can mess up your autonomous, teleop, and like much more. So you always want to use encoders, which are basically sensors normally inside the motors, but as we said, you can use odometry, which are external encoders as well. But for now, we're just going to be using the encoders inside of the motors, and that basically checks if like how many like ticks or rotations the motor is running. So like if it goes against the wall, since the motor is moving, the encoder value won't go up. So now, so basically to fix that, we can just delete this one line of code, and we just don't want that sleep function anymore. So instead, we're gonna put a while loop, and also we're already using the encoder, so it's good we put this line here, or you would have to retype this like when you're using the encoder. So make sure you have this in your like initialize statement. Okay. So basically, now that you're back here, while, and then you want to check the left motor dot get the current position. Oh, I spelled current wrong. Position, and then parentheses, and then you want to make sure we have an error here. Oh yeah, okay. So basically then you want to make sure that's less than, and now, so basically this is what you know. So basically they're using a specific type of ND mark motor here, and that's how many ticks. So in this motor, I'm just gonna write a comment. You do not need to write this. So 120 ticks is equal to 1 full rotation of the motor. That means how many ticks is equal to 1 rotation. So if you want to write let's say 5 rotations, it's much easier to write 5 times, which is like that star when you press shift A, 5 times how many number of ticks. So like in each motor, if you're using a Tetrix motor, it's like 1440. If you're using like different motors, they're like different number of ticks. So just make sure in your motor specs, you just want to make sure how many ticks it has, and you just want to change its value accordingly. So then once you have 1120 ticks, you just want to put 1120, and this should basically run 5 rotations, since 1120 is 1 rotation times 5 rotations. This basically makes it much faster, so you don't have to actually multiply 1120 times 5 and then put that value here. Just makes it much more efficient. And then you just want to say, and then you just want to put nothing here. That means it'll just be in a loop until the left motor like increases, because the power is here, so the motors are running until that encoder reaches 1120, and then it'll power it off and then stop. So you can just press rerun again. You can press stop and rerun. It's still building, like if you're wondering, just installing yours might be faster, so yeah. Okay, and again it'll have Java 8 will open shortly, hopefully. Yeah, okay, Java. Okay, now that the simulator opened, so now you can make sure to click two wheel bot, click that, and then over here you want to go to whatever you named it. I named it auto tutorial, and you can also place your robot at the back if you don't want to like running and trampling stuff. I know it looks weird. just press init and then press start. So now it should move 5 rotations and then it stopped. So 5 rotations, it's basically like 1, 2, 3, 4, 5. I don't exactly know how many tiles, but like you can check by like decreasing this number and then it should like be less. But that's basically how you run an autonomous using an encoder. So that's basically all we have for